Hey guys, hope that you're doing well today. I'm so sorry I'm not here again. My son is still sick. I took him to the pediatrician. They have him on breathing treatments every 4 hours, and I thought it best to stay home with him, take care of him, try to get his fever down, and I do plan on being back tomorrow. Whether that means my husband stays home or maybe prayerfully he'll be better tomorrow. But you do have a sub today, and it's Miss Paget. She obviously was a student teacher. I feel as though most of you know her. She also was the maternity sub for both Miss Kinder and Miss Johnson this year. So I feel that you are in great hands. You're going to watch the lesson, work on an assignment, and she will help you in whatever way she can. Okay? So a couple of reminders. You need to upload your survey topic and your 2 groups on Google Classroom. Make sure you open up a document and type the topic and which 2 groups you are surveying. I will say my first hour had like 5. My second hour had almost everyone except for 5. My third hour had everyone except for 2. My fourth hour is a mess. Let's get it together, guys. My 6th hour only had 2, and my 7th hour only had 1. So my last half of the day, you guys got to really make sure you upload your topic. I'll be sure to comment on it to let you know, give you feedback. Make sure that the 11.1 practice was turned in. If not already, just turn it into the bin. You're going to get an 11.2 practice today. It is due tomorrow if you don't finish it. Again, we're going to watch this video, and then you'll work on that practice, and Miss Paget can walk around and help you in any way she can. You do have a quiz tomorrow over 11.1, 11.2, and 11.4, and then the same thing on Friday. Okay, so let's talk about 11.2. Awkward pause. I have my son in my lap. Can you say hi? Can you say hi in English? Hi. No, okay, cool. He said roar, if you heard that. We're going to be talking about areas of circles and sectors. Areas of circles and sectors. So before, in 11.1 was about the circumference, which is all the length all the way around the circle, right? And then we learned also about what we call arc lengths, which, if we're talking about pizza, it's a single slice of pizza. So I'll cut this up. I don't know if you can even see in all the blue. It's a single slices crust. That's the arc length. Well, area is the cheese of the pizza, so all the inside. And a sector is a part of the area, so the same idea. Area is all of the cheese. A sector is 1 slice's cheese on the pizza. So we start with the area formula of a circle. Believe it or not, you have seen this formula before. A long time ago in elementary school, you used it a lot. There is only one formula, and it has a radius in it. So if you're ever given the diameter, you will have to convert it into a radius, and we can talk about that in a second. But the area formula is A equals pi r squared. I'll give you a second to write that in. A equals pi r squared. Pi r squared. So when you use this formula, the only thing that you can plug in is a radius. So if you're given a diameter, and the diameter was 14, okay, you can't plug in the number 14 because 14 would be the diameter. You would have to plug in the radius, and we know the radius is half the diameter. So in this case, you would plug in 7 for the radius. You would square it and then multiply times pi, which we will practice right here in our first 4 examples. Find the area of a circle with a radius of 4.5 meters. There's only one formula, and it is A equals pi r squared. So in this particular example, find the area of the circle with a radius of 4.5 meters. So our radius is 4.5. So I'm going to plug in A equals pi times the radius, 4.5 squared. Let me grab a calculator. The most common mistake I feel as though I would see students make, I would have out a calculator so you know, this is not the same as doubling. You are literally typing into your calculator 4.5 times 4.5. It is not the same thing as 4.5 times 2. So remember, the correct way is multiplying. You're squaring, so you're multiplying this number by itself. 4.5 squared is 20.25. Now we're going to multiply that by 3.14. We are still going to round the same way since we rounded pi to 3.14. That's the hundredths place. Our answer will also be rounded to the hundredths place. So 63.59, and it would be meters squared. We found area. Anytime you find area, you're going to have a squared answer. This means you could fit 63.5, give or take, square meters, literally squared, 1 meter by 1 meter boxes inside of this circle. Okay, so anytime you answer an area, you've got to have that little squared. Okay, but the second, find the radius of a circle with an area of 176.7 square feet. So the area formula, area equals pi r squared, but this time we are given an area of 176 square feet. So we're going to plug that in for A, the area, 176.7, equals pi r squared. So now we're doing algebra, okay? So whenever you solve an algebra problem like this, you want to solve for r, right? That's our end goal, solve for the radius. But the radius is immediately attached to that squared. So this is like a unit. You have to get r squared alone first before you can get rid of the squared. So you want to ask yourself, what is this pi doing to the r squared? Well, it's multiplying. So the opposite of multiplying by pi is dividing both sides by pi. Now this is when you want to have your own calculator out. I will pause one more time for you to have your calculator out because I'm going to teach you how to have the exact answer. Okay, we're typing in 176.7, and we're dividing by 3.14. You get a very long answer. It says 56.27388533503, so on and so forth. Do not clear the calculator. Leave it. Leave the calculator. It says 56.27, blah, 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 blah. Do not clear the calculator, because to get the exact answer, you can leave it in your calculator, especially having a 4-function calculator, and all you have to do is hit the square root button, because you have a squared, right? We have a squared. We want to get rid of it. R squared is by itself. Now we want R by itself. The opposite of squaring is square rooting. So we're going to square root both sides. This cancels out the square on the right side, and we just have R. On the left, I'm just going to hit the square root, and we get 7.5. It says 0. You can put 0 if you want, but you don't have to. And this is radius, so we're just going to put feet. It is not square feet because a radius is a length. It's a part of the circle. Let me see if I can get a better color. It's literally a length. So in this case, it is 7.5 feet long. Okay, it is a length, not how many squares can fit inside. All right, number 3. Find the area of a circle with a radius of 8.5 inches. So area equals pi r squared. Same idea. You want to look, 8.5 is attached to the radius, so this one's easy. We just plug in the radius. Area equals pi times 8.5 squared. I'll wait a second for you to type it in your own calculator. The first thing you should have typed in your calculator was this squaring. You should leave the pi alone for now, so just drop down a pi. 8.5 squared is 0.25. Multiply that times pi, so times 3.14. 226.5 0.87, and this is area. This is area. So it's going to be inches squared. The last, find the diameter of a circle with an area of 153.94 square feet. So this time we want to find the diameter. But this formula, this area formula, because they gave us the area, would only help us find the radius. So this is when you need to know the radius times 2 is the diameter. So we find the radius, and then we're going to multiply it times 2 so that we can find the diameter. So we have an area of 153.94 equals pi r squared. Again, our goal is to get the radius by itself, and it's being squared. So we have to get the radius squared by itself in order, to get the radius by itself. So this pi is multiplying times r squared. We're going to divide both sides by pi to cancel out the pi. So 153.94 divided by 3.14, which means the radius squared is, again, do not clear your calculator, just leave it, 49.0 blah 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 blah. Just hit the square root, because the square root is the opposite of squaring, so r would be by itself. The square root of 49, it's 7.001, which should be 7, and this is feet. But this is the radius. I don't want the radius. I want the diameter. So if the radius in a circle, if the radius is 7, that means the diameter is 14, and it would still be feet. Okay, so now we move on to talking about a sector of a circle. So a sector of a circle is the region bounded by 2 radii, remember that's plural of radius, of the circle and their intercepted arc. Okay, so all you need to know is, again, we've got a pizza. Can you see the yellow? There you go. You got a pizza. The area is all of the cheese. The sector is going to look like literally one slice, and we're going to be talking about its area. Okay, so a sector is part of the area of a circle. So you're going to see how similar it is to the arc length formula. It'll just be dealing with area instead. So in the box where it says area of a sector, go ahead and write in the area of a sector. Honestly, I usually just write sector, if that's what you want to write. A sector, okay, so sector, think section, okay, so a section of the circle, out of the area. So again, this top part is part of the area out of all of the area. Okay, so sector over area. And then the second part should look very familiar because it's exactly what we did with arc length. We take the measure of the arc out of 360 degrees. So the way I make it look is the measure of the arc out of 360 degrees. Okay, so however you want to make that. But I would highlight around this box so that you could find it later on, because it's how we're going to find the area of a sector, or possibly the area of a circle. So sector over area equals the measure of the arc out of 360 degrees. So we're going to find the area of the red sector and then the area of the blue. If you want to take a highlighter and differentiate the two, the red is on, because I know I have some, beautifully colorblind students, and that's okay. That's the way God made you. The red I just highlighted, it would be arc FE. This portion would be the sector in red, and then the sector in blue is the remainder of the circle. Okay, so sector, we're talking about area. Okay, so whenever we answer for sector, we do write it in square units. So I'm just going to divide them down the page if you want to do that as well. I'm going to do the red over here, and then later we will do the blue over here. So we use the formula where we take the sector, so it's the area of the sector, over the area of all of the circle, and it will equal the measure of the sector's arc out of 360 degrees. I do recommend always writing the formula first while you're still learning the formula. Okay, so we don't know the area of the sector. That's literally what it says. We don't know. I'm just going to put A for area. You could put X if you want. The bottom portion is the area of the whole circle. So we need to find the area of the whole circle, and luckily enough, we know the formula. Area equals pi r squared. So in this circle, we need to identify what the radius is. And radius is in length. The only two things we're given are 120 degrees, which is not length, and 14 feet, which does go from the center to the edge. So this is our radius. Area equals pi times the radius, which is 14, squared. So remember, in your 4 function, you're going to do 14 squared, which is 14 times 14, which is 196. Thank you, honey. There's still more applesauce. Okay, bye. So 3.14, he stole my calculator. Where did it? Yeah, I'm crying too. Which is 615.44. So the area of the circle is 615.44. Equals the measure of the arc. Remember that this fraction, just like before, give me a second, this fraction is still in degrees, just like the arc length formula, and this fraction is still in length, if you want to mark that above. It's the same thing. Length equals degrees. Okay, so we're trying to find the measure of the arc, of the red arc, in degrees, which will be the same as its central angle, 120, out of 360 degrees. From here we do what we've always done and cross multiply. So we have 360A equals 615.44 times 120 is 73,852.8. Divide by 360. So the area equals 205.15, and this is area. So you're going to answer, we're looking at feet, because that's what it told us the radius was. So this is in feet, feet squared. Okay, and then we'll do the blue. It's the same formula. Take the sector, put it over the area, and it equals the measure of the arc out of 360 degrees. So the area of the sector is literally what we don't know. The area of the blue sector, I'm going to put A again. The area of the circle, this is why these kinds of problems are so nice. It's the same circle, so the same area formula, the same radius, and the same area of the circle. So 615.44 equals the measure of the arc. It is not 120 degrees. You need to remember, circles are 360 degrees total. So when the red arc makes up about 120 of it, we have to subtract from 360 to figure out what the blue arc is. So 360 divided by the 120, which is the red arc, okay, will give me 240. The blue arc will be 240. So 240 out of 360. Then we do the same process, cross multiply. We get 360 times the area, and it equals 615.44 times 240, which is 147,705.6. Divide by 360. Divide by 360. And the area equals 410.29. Again, same circle. We're answering in feet, and it is area, so feet squared. And here's how you can check. We know the area of the red is 200, So the area of the red, which is this one, is 205.15, feet squared. We also know that the blue is, what did we say, 410.29 feet squared. Together they make up a whole circle, and we know the area of the whole circle is 615.44. Guess what happens when we add the red sector, which is 205.15, added to the blue sector, which is 410.29? It is 615.44. If you don't believe me, add them, and they will equal the area of the whole circle, as they should. The only other way you will see a question using the area of a sector formula would look like this, where this time we're finding the area of the whole circle. So the whole circle, we know the area of, you see how it's written in red, you see how it's written on the outside. We know the area of this red sector. So we're going to use the area we do know to find the area of the whole circle. I think these actually have less work because when we go to plug in, we take the sector, put it over the area of the whole circle, and it will equal the measure of the arc out of 360 degrees. So the area of the sector, again, we said it's what's in red. It is 214.37. We do not know the area of the whole circle. That's what we're trying to find. So I'm going to put A for area. The measure of the arc, so the arc that corresponds with the sector we were given, is 85 out of 360. Cross multiply, we get 85 times the area, and it equals 214.37 times 360. And you get 77,173.2. Divide both sides by 85. Divide by 85. And the area is 907.92. Let's see what it is. It's centimeters squared. Again, we're still finding area, so it is centimeters squared. Okay, so that's the end of the formula. Now we're just going to talk about area of shapes, such as the next question looks kind of like a sideways ice cream cone, if that's the way you want to look at it. But you want to look at this. We're going to find the area of this shape. We want to remember the area of, all the shapes. If it is a circle, I would write this in because it will become very helpful when we go to do area or volume. You need to know area to do volume. The area of a circle is pi r squared. To find the area of a rectangle, or even if you want to call a square, it's going to be length times width. Can you see that? Not really. Length times width. You can kind of see that one better. A triangle. Area is 1/2 times the base times the height. And then the last one is trapezoid. You do need to know a trapezoid. A trapezoid has two sets of parallel sides. Hold on. It's one set of parallel sides, sorry. One set of parallel sides such as this. If you want to draw a picture with it for reference someday. A trapezoid, you take 1/2. You add the parallel bases. That's what base 1 and base 2 means. These are the parallel bases. Sorry if you can't see the purple on the blue. Let me edit it. There you go. I threw in some yellow. Hope you can see that. And then it's times the height. So I would write those down. You're going to need to know them for volume. You also just need them for this section because they're compound figures we're going to be dealing with. Compound means that there are two shapes, in one. And so you want to break it down in which shapes there are. So it looks like we've got, a semicircle, which we could venture to say is half of a circle. And then the other thing that we've got is a triangle. You know, plus we got a triangle. And our goal, our goal is to find the area of all of it. So all of this together. So that's why there's a plus sign between them. We're going to find the area of the semicircle, which will be in red. And then we'll find the area of the triangle, which is in green. And then we will add them together to get the area of the whole thing. So let's start with a circle. We are going to use the formula, okay, to find the area of the circle. But then we only want half of it. So we're going to find the area of all of it and then half it. Okay, so we want to find the radius. So in our semicircle, looks like this is what we're given, and it is the diameter is 7, which means if the diameter is 7, the radius is half of that, which would be 3.5. So that's what we are going to plug in. Pi times the radius squared. Okay, so we're gonna, again, you gotta do 3.5 times 3.5. Okay, so we have pi times 12.25. And then times 3.14, we get 38.465. I'm just going to leave it on my calculator because, again, I only want half the circle. This area formula finds the whole circle. So I need to take half. So divide it by 2. I did not clear my calculator, and I got 19 point, we can round now, we're at the end, 19.23. So that's area of half of the circle. Now we want to find the area of the triangle. So area for a triangle is 1/2 base times the height. The only thing to remember about a triangle and its area is that the base is always a horizontal line, and then the height is always vertical because we measure height vertically. All right, so 1/2. Our base, our horizontal line, if you will, is going to be 7. And then our height is also going to be 7. We are going to end up with a decimal. I'm going to make this smaller. Hold on. So however you want to do this, it doesn't matter what order you multiply in. If they were even numbers, we would multiply 1/2 times an even number, but I'm just going to multiply these two together. I'm going to drop down the 1/2, and then I'm going to do 7 times 7, which is 49. So again, all I did was multiply the 7s. Now I want half of that, so half of 49 is 24.5. So now I just add that with the 19.23. And my final answer, the area of all of our ice cream cone up there is 43.73. And then this is written in meters, so it would be meters squared because we just found the area. We figured out that there are 43.75 small little squares inside of this shape. All right, we've got one more to do. A farmer has a field with a shape shown. Find the area of the shaded region to the nearest meter. So let's look at what shapes we got. We got an easy one, right? We've got this shape, which gave us 2 hints. It gave us the side lengths are 8, and then the opposite angles are 90 and 90. That means that this is a square. So we're going to find the area of the square, and then we have a half a circle. Just follow me for a second. And we have another half a circle. And what we know about them is that they both have a diameter of 8. All right? So if one of them's a half and the other one's a half plus a half makes one whole circle. So we're going to find the area of the square, and then we're going to add it to the area of the circle. So the area of a square is always length times width. So in this case, length, we could say is 8. It really doesn't matter which one you say is which because we're just multiplying them. The length is 8, and then the width is also 8. and 8 times 8 makes 64. 64. Can you see it at the bottom? I'll fix it. Then we're going to add it to our circle. The area of a circle is pi r squared. So all we need to know of our circles is the radius. So again, they're the same. They're literally the same circle. They have the same diameter, which means their radius will be the same as well. So the radius is half the diameter. So if the diameter is 8, the radius will be 4. So area equals pi times 4 squared. Hopefully you know that 4 squared is 16. 16 times 3.14 is 50.24. So now all we do is we add them together, and we get 114.24, and this would be meters squared. Okay, this lesson was way longer than I had intended it to be. I'm really sorry. I'm doing the best I can. My son does not feel well. I've opened up 3 bags of gummies, 2 applesauce packets. There's gummy all over my desk, and life is a mess. And I love you guys, and I miss you, and you're going to work on this practice paper. Please make sure you ask Miss Paget. She can walk around and help you. But also, I'll be back tomorrow. We do have a quiz, and that's our life. So I hope that you guys have a wonderful Tuesday.